Okay, the only bit that I haven't shown you here is where to find the data, but as I said, it's all under ADN stats data. Here it is, the raw data or the sample data no guitar and the sample data with guitar. If I just select attract score for variable 1, just thinking about it. Okay, so I get this graph over here. Now, that is showing all the data. So that's the data with the guitar and without the guitar. And it's not really worth bootstrapping all the data together. I need to separate it out into a subset variable. So down here, you can have variable 2, and I can click on that other variable and it splits it. Okay, so this is the 9 or so values. Is it 9, 3, 6? 9 values with without a guitar, and this is the 9 values with a guitar split. If I go and analyze that, and I'll stick again with the median, record my choices, it shows you the difference between the two medians of the sample data happens to be a 1.5 increase. Now, back in year 11, if you compared a box and whisker plot like that, you would definitely say that the guitar has an impact in the population. Back in the population of New Zealand adult women, there would be they would find a person with a guitar more attractive than without. Just looking at the box and whisker plots, right? The grade box and whisker plots. The lower quartile is above the upper quartile, and it's a definite shift apart. Now that you're in year 13, we do bootstrapping. So if I record my choices and do one bootstrap, now this is actually bootstrapping the difference between the medians. This is actually randomly selecting from the whole set of data. Okay, and all we're going to be plotting is the difference between the two medians that this random selection process collects. So notice here the new difference is this amount. The old difference was greater, 1.5. If I do that 5 times, so this is the same idea as what you've just done. There was no overlap between the two spreads. When I do it 5 times, it's going to record the difference between the two medians each time. There's the first time, big difference, about 1.5. Randomly selecting from all the data, this timing recording the difference between the two medians. Second time, third time. I'm going to speed it up a little bit. I'm not going to animate, I'm just going to make it go. How do I stop it? Maybe I'll do it 20 times. Maybe that'll speed it up. There we go. Okay, they were all positive differences, weren't they? Did you see the arrow flick around the other direction? Okay, so that with that random sampling, if you watch the arrow, it always says the person with the guitar is more cooler than the person without the guitar. And down the bottom, notice the scale's changed. We don't have the 0 to 10 or 6 to 9.5 anymore. These two scales are the same. This is actually going to plot the length of that arrow, which happens to be the difference between, say, 8 and 6.5, which happens to be 1.5. But every time I resample, this arrow is going to drop down to the bottom. If I do it once, you'll get the idea. Okay, and that's going to drop down and plot one value at 1.5. So with resampling, the difference between the new medians is 1.5. Do that, say, 20 times. Again, they all stayed positive. The differences all stayed positive. Do that 1,000 times. The difference between the bootstrapped medians, oh, there's one at 0. They can fall as big as 2.75. There's one there. But mostly it happens to be the same as the original sample. Okay, so using a 95% confidence interval, which is this button here, okay, watch this sentence. It is a fairly safe bet, or you could say I'm 95% confident that New Zealand adult women find the median attractiveness of a male more attractive with a guitar in the vicinity of 0.5 to 2.25 more attractive. So the true population median for New Zealand women, adult women, falls somewhere between 0.5 and 2.25 based on my sample of 9 women in New Zealand.